So hello everyone, and well, first of all, thanks to the organizers for such a great job, and also for the opportunity to present here. So today I'm going to discuss algebra Algebra of Graphics, which is a project I've been working on for the past few years, which is basically a library built on top of Makie to kind of simplify the creation of complex data visualizations. So I will start by giving some introduction about the problems Algebra of Graphics attempts to solve. Then I will give an overview of the Algebra of Graphics library. So I will discuss its philosophy, how to use it in practice, and how to integrate it with Makie. And given that it's, I think the background of different people here is very diverse, I will try to give a high-level overview, also with many practical examples. But of course, I'm open to discuss, to kind of dive deeper during question time. Then I want to discuss. Sorry, are you changing? Right? What's happening? I have full screen breaks. That won't work. Is there a way to remove the cursor while we're at it? But, yeah, but it's not mine. Okay. Sorry. Yeah, I felt a bit silly for a second. And yeah, so sorry about that. And then I will, we'll discuss a little bit what I think is the best way to integrate the kind of algebra of graphics visualization component with a machine learning pipeline, and also how one would go about integrating algebra of graphics with a graphical user interface. And finally, I will kind of give some general conclusions about the project and where I believe it is going. So first thing first, the problem that we're trying to solve is to represent data graphically. And this, I think, is a very kind of diverse field. So many different data visualizations exist. But even though it is so diverse, I have the feeling that many plots, especially in kind of statistical plots, they follow a similar procedure. So generally, one will start by grouping and processing the data so it can get grouped by some categorical variables, and some transformations are applied. Then you would try to encode graphically several aspects of the data, which could be either categorical variables that could be encoded, for example, in the color palette, in the marker shape, and the line style, and so on, or some continuous quantities, which can be encoded, for example, in the X or Y position, the marker size, the color gradient. Then you would choose what's your plot type, a scatter plot, a bar plot, a line plot, and whatnot. And then you would combine many of those plots into a single feature. So this is a simple example that I like to show. So it's data from some recording of penguins, when you can show basically on the X and Y axis, you chose the shape of their bill, so either the length or the depth. And you group them by species, and you color them by their body mass, and with a linear fit on top. And this is the example that I have in mind. Now, do I feel a bit silly for showing this kind of old school scatter plot after 1 hour of kind of fancy data shaded things? A little bit, but it was also too late to change it in the coffee break. And but still, I mean, of course, you can decide your plotting recipe. So if you prefer density heat maps with a non-linear color scale, then of course it would work with the algebra of graphics machinery. So what's the philosophy? My basic idea was to create some sort of a language for data visualization, kind of a syntax that would be based on Makie. And the idea is that one would not focus so much on kind of the steps that you need to follow, but it would be a more declarative approach. So the goal of algebra of graphics is that it would kind of translate a question about the data into a visualization. Then it attempts to remove as much cognitive overhead from the user as possible So all the defaults, they try to be sensible. So we discussed before about perceptually uniform color maps and whatnot, or also the data format. You should not worry so much about formatting your data. The software should do it for you. And it should be broadly applicable. So you should support predefined analysis, transformation, and plotting recipes, but also your custom ones, the predefined ones on future needs. And it really makes a strong effort to be modular, so that the user would initially start the analysis by defining their own building blocks, and then it would combine them in different ways. And actually, that's where the name Algebra of Graphics comes from, that these blocks are combined with algebraic operations, such as multiplication and addition. So the key intuition, now this is all very abstract, but I give many examples, is that you can use multiplication to combine information within the same layer of a plot, and then the addition would superimpose different layers. And as a lot of information is shared across layers, you can actually simplify your formula using the distributive property and factoring out the parts that are shared among layers. So I'm going to do a demo with my favorite data set, which is a set of measurements from penguins living in some islands. So you would have the species of the penguin, the island that they live in, the measure of their bill, of the flipper, the body mass, and the sex of the penguin. And so it's a kind of a typical example for statistical plots. And the first thing, as I mentioned before, is you define your building block. So of course, first you need to say what is the data that you're working with. So in this case, it's this penguins data set. And then to what variables you encode and how you encode them. So this is basically a small kind of mini language similar to what you would find in data frames to do some kind of fast on-the-fly processing. So here I'm saying that as a positional argument of the plots, I want the bill length and bill depth, and I want to rescale them from millimeter to centimeter, so I divide by 10. And I want kind of a more elegant name, because the name as it came in the data frame is a bit ugly to write on the axis. And then I would do something similar for other attributes. For example, the body mass, I want to use it to define the color of the scatter plot. And again, I do some conversion and some renaming of the column. And inside the species, I want to use it as a categorical variable, and I want to use it to inform the marker shape. And then it's just a matter of combining these things. So this is the simple thing that you can do, that you just combine the data set and the fact that the position arguments are the bill of the penguin. And then as you add building blocks, the plot becomes richer. So for example, I can add now the body mass information, and we color the thing and display the color bar. And I would add the marker shape information as the species, and then I would get also the same plot, but it will tell me which of these basically each of these points, which species does it belong to. And this is as far kind of unprocessed data goes. But of course, you can also do kind of some simple analyses that are built in, and you can create your custom ones. So this is just a linear fit. And in this case, there are no categorical variables to group. So it's being fit to all the data. But again, you can group by species and do 3 separate fit lines, one per species. Again, the syntax is the same as before, and you can basically add these plots together just by simple addition, and you get the kind of the more complex figure that I showed at the beginning. And this, of course. And here you will see what I was talking about, that a bunch of information is actually shared across these layers. So it's a bit silly to write it like this, and you can write it a bit more compactly by factoring out the information that is shared. This is the phenomenon that I think occurs pretty often in these plots. And I think the last thing that I want to show a little bit in the overview, basically the overview part of the talk, is that it's not only kind of attributes of a single plot that can be informed by the variables, but also the layout of the figure. So for example, here I can change my mind, and I no longer encode the species in the marker, but in the column. So which column of the layout, different columns of the layout will correspond to different species. So you get this type, of plots where basically every different subplots correspond to a species. And again, I think this is, I want to show this Q example that I stole from the R documentation, but I think it's interesting that it's another case where it's helpful to add different layers, because one trick that they do often is that they create a semi-transparent layer that is ungrouped and a kind of full opacity layer that is grouped. And so you can create these facet plots where you can kind of compare each, basically each subset with the whole data. To be kind of perfectly frank, this actually, I'm hacking around it. This currently is buggy. But I thought if I put it in the slide, then I will be strongly motivated to fix it sooner rather than later. So don't try this at home yet, but should be fixed soon. And I mean, I thought it was like, this is being recorded, so I have to say it. And of course, so far I've only shown, I mean, scatter plots, but a bunch of recipes are possible, and you can check out the what is that? The Algebra of Graphics documentations. There are many examples in the tutorial on how to explore these data with penguins, and also you can look around in the galleries to see different types of visualizations that are available. But in principle, kind of everything that works in Makie should ideally work here, and if it doesn't, kind of open an issue and hope for the best. I think is the approach. So that exactly, open praise. That was about it in terms of a kind of overview on how I believe this is used. And in terms of, I want to discuss kind of a little bit how it works in terms of pipeline, because I tried to make it as simple as possible so that every bug that occurs, I can say that it's actually a Makie bug, because I'm offloading everything to Makie, because I know that I'm a very ineffective maintainer. So the more I can kind of outsource, the happier I am. So the way that so that is my design goal. And in order to achieve that, the pipeline that I thought about was as follows. So the thing that Algebra of Graphics is actually doing is to combine these kind of algebraic blocks together into kind of a list of layers. So just kind of computing out the whole formula. Then it's basically grouping and processing the data based on these on the specifications that you get in these layers, and this is done actually by struct arrays, which was the most lightweight kind of a grouping mechanism I could find, but I might want to change that. But there is a little bit of data wrangling that is done inside Algebra of Graphics. And then finally, use the draw command to actually draw the plot. And this is entirely done by Makie. So I use the kind of the very good drawing and layout capabilities of Makie for this. And actually, this interaction, I think, is something that is worthwhile to discuss. And this, I think, is kind of a unique feature, because this approach of kind of associating variables to plot attributes is very common. Many libraries exist. This, I think, is a bit special because it has underneath an extremely customizable library that is Makie. So you can kind of decide where you sit. If you do the whole thing in Makie and the whole thing in Algebra of Graphics, or you kind of cherry pick which part you do in which library. So for example, the first thing that just works out of the box is that all the customization that Makie has, they're just forwarded. So if you want to change the aspect ratio of the axis, or the figure padding, or the background color, the resolution, this is all just passed on to Makie, so it should just work. And even if you don't do that, and you just create your plot with all the defaults, no customization at all, then you get, let's say, this example plot, typical facet plot. Then what you can do is you can tweak it after the fact. So the Makie objects are still accessible. So you can kind of dig around in this grid and kind of iterate through them. And for example, change the rotation of the tick label. So without it, you get the horizontal ones, but if you're vertical, you just rotate after the fact. And finally, even within a single figure, you can decide that some plots are easier to do with Makie and some are easier to do with Algebra of Graphics. So for example, here I'm just saying that I want to create my Algebra of Graphics plot, but I want it to span only the second and third column of an existing layout, and the rest of the figure I do it with Makie. I don't really care. So you can kind of combine them within the same figure. And I feel like these are kind of under advertised features in the documentation, so I thought it was worth to kind of say them out loud, especially for those of you who felt a bit limited by Algebra of Graphics. That I can't treat it the way I want to. This is, I think, the kind of your best bet. And in the second half of the talk, instead, I wanted to basically address kind of a slightly less traditional use case, which is basically the scenario where you don't come from this kind of pure statistics world, because I think it's very easy to think that grammar of graphics is just restricted to those data sets where you already have a bunch of interested variables. So you already have the species, the build measurement, the flipper measurement, the island measurements. But one thing that, well, like with hindsight is obvious, but I think it's worth mentioning, is that some of these columns may be kind of synthetic columns that you created with your analysis, and then you just add them to the data and go on using Algebra of Graphics. So one simple example that I'm going to do is, let's say you're actually doing just some classification task, always with this data, and you're predicting species. Then the way you would use, based on some other features of the penguin, I'm not sure what kind of feature of the penguin will tell you the most about the species it belongs to, but I'm sure some of them will tell you something. And the way that you would do this task, that you would kind of run your model, and then you would simply add the columns, because you would have to have split the data in kind of training and testing, so some Boolean variable, and you would have the prediction of the model at the very least, so the predicted species, another categorical variable. And then you can just go on as usual with Algebra of Graphics. So you do maybe a little transformation on the fly, so you can kind of use this simple syntax to generate a new column that tells you whether the prediction was correct or not. So this error column, or you know, another variable that's more explicit about whether it was kind of a training or testing sample. And then again, you're able to generate kind of the usual diagnostics for the model with the Algebra of Graphics, syntax. So this is a very simple case where I'm just plotting on average how many errors I make based on the species in both training and testing. But you could think of much more advanced diagnostic, figuring out how the error correlates with what variable. So on what kind of range of the data set you're making the most mistakes. So I think all these plots become possible once you add the correct variables to your data set. And this brings me to the last, I said it was the second half, now this is the third half, but second half was really short in my defense. So I hope you're not gonna mind. Which is how I kind of see this whole data science pipeline, which is actually a very complex pipeline and the kind of non-straightforward, where many things happen at the same time. You're gonna filter your data, do some pre-processing, maybe augment it, do some modeling, some regression, some other modeling to cluster it, classify, validate, and have some kind of diagnostics for all of these, and some visualizations along the way to make sure that your models are making sense, and there's, even though it runs and it gives an output, you want to kind of look at the data, see what's happening to make sure that you're not missing anything silly. And these, I believe, I mean, traditionally, a lot of people do it with code, but I think it's a good use case to have some sort of kind of a graphical user interface that guides you. And this type of graphical user interfaces were one of the reasons why I was so eager to start an Algebra of Graphics, because if I were to wrap the whole of Makie in a GUI, it would be very hard, because all the Makie commands can be very diverse with each other. So how can I translate the output of the buttons and the widgets into a Makie command? Instead, with a unified syntax, I think it's easier. So I've been working with my colleague, Mattia Bergomi, at a small company that we are setting up. Hopefully it will start existing in the next couple of weeks, Lehman Research. And basically streamlining this kind of data analysis and visualization pipelines is one of our main goals. And I've been working, it's completely unpolished, so I will actually only show screenshots for fear that it crashes, which it might. There is one such prototype of a GUI that's based on Algebra of Graphics for the visualization syntax. Then it's a web-based GUI, so I'm using the WebGL version of Makie for the interactive plots within the UI. And then JSR, which is another library by Simon to basically communicate between Julia and JavaScript. And then actually most of the components are just custom HTML with some styling from a CSS library that I like, Tailwind CSS. And of course, the whole of the Julia ecosystem is accessible for the analysis and transformations that you might want to do. You can of course incorporate all sorts of models into this. And I'm doing the front end, so of course it's very simplistic. Let's be upfront, but this is what it looks like. So it has kind of two different halves, one on the left and one on the right. And the left half is things you can do to your data. So you can load it, you can filter it, you can process it. And the right half is kind of visualizations and diagnostics. So you can kind of see what came out of what you did on the left. And so after loading the data set, the first thing that you can do is you can filter it. So there's just basically a list of filters that you can use. And again, it chooses the distinction between categorical and continuous variables. So for categorical variables, you get a simple basically set of checkboxes to see which classes you want to keep and which you want to discard. And then as you filter, the whole pipeline updates and you remove those from the data set. And similarly for continuous variables, you would select a range. Of course, fancier selector may be implemented and added, but it's just the same procedure. You filter by continuous variable as well. And then the most and again the whole kind of the change propagate throughout the UI. And then kind of the most complex part is this processing tab, which is done by which is where ideally this should be the most extensible. So it's done by card. I think it's easier to show some example. For example, this is a card for kind of predictive models, linear prediction models, where you have a system of smart autocompletes that would guide you on writing kind of a possible linear model. And then as you call it, it would add some outputs to your data set. So you have new columns that correspond to the basically the prediction and the error of the model that you computed. And so far, I think it's mostly prediction, clustering, and dimensionality reduction. For example, this is how you would do to add a new column that tries to cluster some kind of components on this data set. And again, it works the same way, just as the column. But this is where it's extensible, right? Because you can, if you have a fancy model that's specialized in the kind of data you work with, you can just create a new structure of a new card and tell it what to add, and it will just compose. And finally, so again, this is a very minimalistic interface, but I think it's quite practical. You can not only see it as a spreadsheet, but also see it as an algebra of graphics visualization. So again, you have a system of kind of smart autocompletes that kind of from the data reads what it would be sensible to put as attributes, and it kind of creates this algebra of graphics specifications of the plot. And it has kind of a simple version of the algebraic structure where attributes are things that are shared across all the plots. And in layers, you would put basically the things that you're adding together. So you can generate this kind of slightly more complex plot in a almost code free. In practice, you are writing the same code you would be writing, but it's guided by the interface, so it's quite pleasant to do. And finally, also shout out to Graph Makie, which I'm using then at the end to show how the data is flowing in this pipeline that is being generated. So, for example, here it basically deduces from what variable you're using in the various cards. It's similar to Pluto in what order it should follow the pipeline. So, which card needs the output of what other card. And then you can create this kind of data flows. And so it tells you first you loaded, then you filtered. Then you did a couple of projection, which you used for a further prediction, and so on and so forth. And I'm almost done. So I'll just go through the conclusion and I'll take the questions. So just to quickly wrap up, what we've seen so far is that Algebra of Graphics is an explicit composable syntax for data visualization. And it really tries very hard to be modular. So there are kind of basic building blocks that can be defined, combined, and then reused to define complex visualizations. And that it's customizable. Thanks to Makie, essentially. I didn't do anything to make it customizable, but yeah, you guys did. So thanks to the underlying Makie plotting libraries, many degrees of customization are possible. And we've seen that it's actually reasonably easy to integrate with a machine learning pipeline, just using the tables abstraction, basically. And it should also be easy to integrate with the graphical user interface, and there is ongoing work to do that. So those were the good bits. I think I'm leaving, there are a lot of kind of not so good bits, which I squashed into a kind of very small bit of slide. But I think just to mention that there are, I'm aware that there are issues. So that I think there are many quality of life fixes that are needed to reduce the barrier for users. So it takes a lot to get started. Big latency problem. Then sometimes sorting and renaming things is not necessarily hard. Daytime support exists, but also not great. Different data formats are supported, but if you go too exotic, you're kind of trying your luck. Error bars have some issues. There are some small bugs, especially with alpha transparency. As I mentioned, orientation is also not really supported. So there are some of these are small things to fix, other are kind of larger things to fix, but I'm at least aware that they exist. And of course, there would be some of these I think would be good first issues for somebody that wants to contribute. And then of course, a much bigger issue is how to kind of tap into the kind of interactive component of Makie. So can it work if instead of passing static data and passing observables that can be updated? Or can one make it easier? It was actually Fabian suggested it yesterday, and I think it's a great idea, and it exists in other libraries. Can I enrich the language so that it not only generates the plot, but it generates a full-blown UI, where, for example, some variable is not encoded in the color, but in a slider. And as you slide, the plot updates. I don't think once you have the first one, I think the second is trivial, but the first one is very hard. So work in progress. But again, one of the things that it would be great to discuss later today on what should happen to make this more possible and easy to achieve. And that's everything I want to discuss today. And thanks a lot, everybody, for the attention.
Thank you so much. Questions, comments?
I think there was one from the chat.
Yeah, actually, yeah. That one is asking you have now functions like density or frequency. So what would be the easiest way to do your own?
That's not very hard, but it's also very undocumented. So that's on me. And I agree, unfortunately, because I wasn't entirely, because I think there are some subtleties, basically. on whether it's only using, the tricky bit is that some analyses are only using the data within a given group. For example, like density, it's fine. Well, I'm not sure. But some, for example, computing a mean, it just needs the group to compute the mean. Whereas if your analysis is, for example, a histogram, then you need the whole data to compute the beans, because otherwise it would be completely mismatched. It would be a nightmare. And I think, yeah, I confess that so far your best bet is to see how it's done in the source code and do it similarly. But I think it's yeah, it's important to open an issue and keep it as a kind of a priority thing, because, for example, if instead of a density or a CDF, you want some kind of hazard rate function, then that should be very easy to add. And I think in practice, that's possible, but I think it's a matter of finalizing the interface of these things and documenting it. But so
opening an issue about it would be
opening an
nice.
issue and bugging me in a persistent way. Well, maybe just the former. Yeah, that would be that would, because this is definitely planned that you would create your own custom one.
Question?
So my question is, I guess that's about the orientation point, because one issue we often encounter with algebra of graphics is that some plot types, I mean, most plot types use the convention that the first argument is X, the second is Y, and if there's a third, it's Z, but a lot of them also don't. And, and I was wondering if you had thoughts about how that could be changed in the future so that you accurately map the inputs to the labels. And sometimes, yeah, a good example is as error bars, where you can have 3 inputs, but one is X and 2 others are Y.
I think somehow, at least again, this ties into my philosophy to outsource everything to Makie and be rid of any bugs on my hand. But what I thought is missing on the Makie side is a system for kind of label suggestion. So basically what I would imagine is that if you pass label data, like this kind of named arrays, then part of the job of the Makie recipe will be to inform the labels of the axes. So that would be done at the level of the Makie recipe, that it would have at least a suggestion of what it should be based. And then, so that somehow within the recipe, it would, I think that basically so far the recipe have exactly the information that is needed to draw the thing with Makie. And I think it would be helpful to add more information to them. So the what kind of variables correspond to what axis. Yeah, I think there are some changes that need to happen on the Makie side to make this, because otherwise here it's a bit of a guessing game. So if I have only one variable, does the label go to the X or to the Y axis? Which plot types require color bar? Like it's very hard to, there are some kind of heuristics, but they're not kind of 100% reliable. So I think it's a matter of adding some sort of metadata to the recipes, I think. I would go this way about it.
Okay, thanks.
So, that some things are special case for special recipes. As bad as that sounds, yes. So for example, to guess, we suggested a bug yesterday that for the color bar, it tries to guess that if there are 3 arguments, it's quite likely, and so a heat map with 3 arguments, it figures it out. But if you just pass 1 argument to the heat map, then the heuristics fails because it wasn't expecting that it's a Z component. I mean, that's of course not sustainable. Like you cannot keep updating that. It's not extensible, because if you make your custom recipe, it's gonna fail. So we need to understand how to enrich the recipes so that this works in a robust way. Because that's not the case now.
Sure. Hi. Thanks for this. I was wondering more from a more outsider's perspective also. Algebra graphics has an uncanny resemblance to the GG plot in R, right? So, and I was wondering, given that that is so widely used in our community, and I think it's one perhaps the highest in the library that's most used and everything. I was thinking, how are you now positioning yourself with that? Because I guess many people that would transition from art to Julia many would look for this kind of package and would think, okay, so is this the one that would replace ggplot, or do you see yourself as doing something similar but different? I was wondering about your position
I
on that.
think that, so there are, of course, many things that are the same. So the whole grammar of graphics idea is, of course, layered grammar of graphics idea is, of course, exactly the same, like we need to reinvent there. If you dig deeper, it's quite different, which I think is why, in my opinion, ggplot is extremely popular in R, but an exact clone of ggplot wouldn't be as popular in Julia, because I think just by the nature of the language, kind of Julia users are much more into kind of hacking things and getting things exactly the way they want them, and kind of tweaking and being in control, or at least to a larger extent. Whereas my experience that in ggplot it was more about, but correct me if I'm not an expert, so don't quote me on this. But from my kind of superficial playing around with it, it was a bit more user friendly, which came, and the trade-off was to be a little bit more magical. So here, I think conceptually the difference is this tries to be way more explicit. For example, we need two operators, plus and times instead of one, because from one you have to kind of use heuristics to deduce what the user wants and how they are combined. So this, I think conceptually, this is different because it tries to be kind of no magic, so no macros, no lazy evaluations. So the building blocks are kind of regular Julia code. No guessing games. So that's where it differentiates. And to be honest, I would hope, I think there is ongoing work to create actually a ggplot clone in Julia, but it is tidyr project. And I really hope that it succeeds, because it would be very stressful for me if people come with the expectation that whatever they can do in ggplot, they can do here. And then I have, I don't know, 100 issues that are like, okay, I tried geom type point 2D in Algebra of Graphics and I didn't find it. And then I would have to address those. So that, I think when the users come with the expectation that they know already what they wanted from the previous package, then it's very stressful to address those. So I'm actually glad if there's kind of something else that addresses the use case and I can experiment with a kind of new approach.
So we should move on.
But I want to counter argue a bit. I mean, I don't know. I mean, if people want to use it, then exactly, for example, the summary stats or so, this kind of thing would be very nice. And of course, you cannot do all. So that's why I'm maybe coming back. I had the same question as in the chat. Making it, I don't know how complicated it is. So, but if it's maybe for this simple addition, sometimes binning and then averaging something is not so complicated, but one needs to know how to do it. So maybe this is really the solution, that to crowdsource more the possible extensions of more object. And again, if it's not too complicated, and I have, for example, a use case, and I know, okay, I can do that in 15 minutes or so, because it's not so complicated, then probably every user, even that is not so expert, could do it. So I would really ask for this tutorial, maybe we can do it today.
But it's
how to create this additional layer, type of layer, or
but that's a good question, because yeah, for the kind of the geometry parts of the recipe, it tries to support anything that, with the caveats that we just discussed with Simon and Julius, it tries to support everything that works in Makie, so that's easier. For the analysis, I think, yeah, a great starting point is to make kind of a dev docs on how to create your own. And then I think it can be said, it doesn't need to live in Algebra of Graphics. It can be a system of plugins. So basically you would create your, for example, your plugin for, I don't know, for geodata, maybe there are some analyses that are very common, and you would have a plugin that implements it outside. So this is something that I would love to create, an ecosystem of these things that can live outside. Yeah, that would be, and it's true, that would reduce the barrier for many people, because those who are not kind of too keen to kind of hack their way into it, to just use Yeah, I think that's a great idea to invest in these developer docs.